Today we're going to look at Section 3, Conditions for Parallelograms. You will also need to have that little half sheet of paper that has the 6 conditions for parallelograms. So when you approach these problems today, you do not know if it's a parallelogram or not. So notice there are no markings on the shape. The directions here don't say that you're given a parallelogram, so your goal is to prove it's a parallelogram by linking it to one of the 6 items on that half sheet. If you can't link it to one of those items, then you can't prove it's a parallelogram. So notice how example 1 is worded. Show that JKLM is a parallelogram for A equals 3, B equals 9. So we want to see which one of the rules we can link it to. And then our answer to these problems will be writing out that rule. So when you look at this problem, I see several expressions here on these 4 sides. So I need to figure out what the side lengths are. So I'm going to need to plug in these values. So if A is 3, I'm going to have to come in here and plug in a 3 for A on either side. And then B is 9. I'm going to do the same thing, but I'm going to substitute in a 9 in place of B. So we'll kind of speed our math up a little bit. So JK will end up being 34, and I'll just write that on the picture. And then when we go through 10 times 3 plus 4, we get 34 again. So I do have one set of sides equal. The top and bottom, KL, when I plug in my 9, I get 51. And then on the bottom, 8 times 9 minus 21, I do get 51 again. So I see that both pairs of opposite sides are congruent. And so the way I'm going to show it is that's what I'm going to write out as my answer. I'm going to write both pairs of opposite sides congruent. Both pairs of opposite sides congruent. And so the answer, like I said earlier, is going to be that justification. Okay, we're not going to go through every problem, so I'm going to skip down here to number 3. So number 3, we are asked to determine if the quadrilateral must be a parallelogram. Justify your answer. So when it says justify, those are the theorems that we're going to have to link it to. So when I see this problem, what I see are 3 angles. So I see 107, 73, and 107. So when I look at these this picture, 107 and 73 we consider consecutive angles. And then on the other side we have the same set of consecutive angles. So when I look at my half sheet, I'm looking for the rule about consecutive angles. And so if they're supplementary, then I can justify it's a parallelogram. So if I do the math here, if I add 107 to 73, yeah, I do get 180 degrees. So I can now justify that it's a parallelogram. So I'm going to write that something like, determine if it's a parallelogram, yes. My justification is one angle is supplementary to both consecutive angles. So one angle is supplementary to both consecutive angles. Both consecutive angles. So, and that is my answer. So there's not a whole lot of calculations this section. We're just trying to use some of the calculations to get to the final solution. Okay, I would like you to take a look at number 4. Go ahead and pause the video, and I want you to decide if it's a parallelogram, and if it is, I want you to write down which theorem you can link it to. Okay, when I look at this problem, what I see here is I see this opposite set of angles are congruent. But I don't have anything about these 2 angles being congruent. And I can't really get to the fact that those 2 angles are congruent. I mean, I know these are equal, but these 2 values could be slightly different, but I could still get the 4 to add up to 360. Like, for example, if this one was 101 degrees and this one was 79, well, it still adds up to 360, which is a quadrilateral, but I can't show that the angles are congruent. So I cannot justify it's a parallelogram. So I might say something like no. And then to justify why, I'm going to say only one pair of opposite congruent sides. Only one pair of opposite congruent sides. Opposite, or not sides, excuse me. One pair of opposite congruent angles. So if you can't get it to work out, then you can write your justification as far as why the answer is no. Okay, let's go on to the back. Same idea. I'd like you to pause the video and see what you can come up on this one and then come back. Okay, on this problem or on this example, I see right here, I see a set of I see a set of congruent angles. And I see part of these other two angles are congruent. And what we're going to be able to do on this one is we're going to be able to show the triangles are congruent and then use CPC-TC to help me get to the fact that it is a parallelogram. So I want you to change the way you're looking at this problem, and I want you to see two triangles. Triangle number 1 here, triangle number 2. And when I'm proving triangles are congruent, I do see a reflexive side right here. So let's go ahead and mark it. And now what I see is I see angle, angle, side. So I'm going to make a couple notes here. I'm going to say, actually, let me back up. I'm going to say, let me erase that triangles congruent by AAS. And so what I want to do is eventually, if I can get to both sets of opposite angles are congruent, then I can show it's a parallelogram. Well, now what I can do is I can go ahead and mark, I'm going to put a dot here. I'm going to go ahead and put a dot here. I can now say that those two blue dots are now congruent by CPC-TC. So I'm going to maybe write here CPC-TC shows third angles congruent. So I just need to somehow indicate that the other ones are congruent. Now I do have both pairs of opposite sides are congruent. Or I keep saying sides. Both pairs of opposite angles are congruent. So both pairs opposite, and I'm just going to abbreviate opposite now, angles are congruent. So sometimes you can get to that fact that you can use congruent triangles. We won't do that all the time, but sometimes that does occur. Okay, what I'd like to do is jump down here to the last example. And we are working on a coordinate plane. So we are trying to show that the quadrilateral JKLM is a parallelogram by using the definition of parallelogram. And the definition of parallelogram is we have parallel lines. So I would like you to go ahead, plot these ordered pairs, and then we will take a look at it. And I'm going to do my best to plot it. It's going to be kind of hard sometimes on this iPad. So -1, -6. Let's see. Or -1, let's see, -1, 1, 2, 3, 4, 5. So it's about right there. -4, -1, 1, 2, 3, 4. So there we go, right there. So this is J. This is K. 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, I think is right here. That would be L, and then M is at 7, 1. 1, 2, 3, 4, 5, 6, 7, 7, -1 down here. That is M. Now remember when we go ahead and name it, we're going to name it JK, or we're going to connect the lines JKLM, JKLM. Okay, so when I look at it, I want to try to show that the opposite sides are parallel. So I want to look at slope, and I want to compare slopes for KJ and LM. I'm trying to get them to be the same. And then I also want to double check that KL has the same slope as JM. So I need to count that out. So I'm going to start with KJ. And so the slope, it looks like it's going down 1, 2, 3, 4, 5, did I count that? 1, 2, 3, 4, 5. And then, where am I at? Over 1, 2, 3. So I have a negative 5 over 3. And then I'm going to check LM. I'm going down 1, 2, 3, 4, 5, 6 over 1, 2, 3. Now, right there, that tells me those two lines are not parallel. So I'm going to go ahead and count the other two sides, but I probably could stop right here and say that it's not a parallelogram. But if they were the same, we would want to double check the others. So KL is a slope of 1, 2, 3, 4, 5, 6, and then over 1, 2, 3, 4, 5, 6, 7, 8. So I have 6 over 8. And then JM is up 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. 5 over 8. So I have that case on both of them. So I'm going to say here, not a parallelogram. Now, if I would have decided it was a parallelogram, I would need to show that both sets of opposite sides are parallel by demonstrating that with slope. So that is section 3. Make sure you do have that half sheet of theorems, and you will be using those as all of your justifications.